Dear students, wish you a very happy new year. Now, today we will look and we are going to study the Cayley-Hamilton theorem, which is a very important theorem for matrix algebra. So let us look what is the statement of Cayley-Hamilton theorem. Cayley-Hamilton theorem was given by two mathematicians. The first is about Cayley-Hamilton. He born on 26 January 1895 and he was a British mathematician. Second, his partner was the William Rowan Hamilton. He born in 1805 and his major contribution is in the area of physics, astronomy and mathematics. Okay. So now let us look what is their beautiful theorem which is known as Cayley-Hamilton theorem. The statement of Cayley-Hamilton theorem, it is very well known statement and very important in the theory of matrix algebra. That is, every square matrix satisfies its own characteristic equation. Every square matrix satisfies its own characteristic equation. It means what? You know the characteristic equation of nth order square matrix A is may be written as A minus lambda I, and this is minus 1 power n lambda power n plus k1 lambda power n minus 1 plus k2 lambda power n minus 2 up to kn is equal to 0. Of course, you are already knowing, we have already discussed in the previous PPT, and if for the beginner you can view again that PPT which is in the name of eigenvalues and eigenvector. So lambda is eigenvalue. So it means according to this theorem, this satisfies its own characteristic equation. It means you may replace this lambda by capital A. And what is capital A? A is the matrix, a square matrix. Then very easily you can write this equation. Okay, minus 1 power n, a power n plus k1 a power n minus 1 plus k2 a power n minus 2 and so on up to kn. I is what? Identity matrix. Okay, so this is about the statement of Cayley-Hamilton theorem. Now, there's some important point of Cayley-Hamilton theorem. If you simplify further, then you will be able to express the A inverse. And what will be the formula for A inverse? The formula will be this. A inverse is minus 1 by k power n and minus 1 power n a power n minus 1 plus k1 a power n minus 2 and so on up to kn minus 1 I. This is a beautiful formula, and with the help of this formula, the Cayley-Hamilton theorem gives another method for computing the inverse of a matrix. And you know what is the importance of inverse of a matrix. This is very suitable, especially in case of large matrices. You know, we always discuss to find the solution of algebraic and transitive, to find the solution of linear system of equation. A is equal to x, b, or you can say ax is equal to b. Ax is equal to b. So ax is equal to b. You can write this as a linear system of equation. Then what is x? X is of course A inverse b. To get the solution of any system of equation, it is very necessary to find the inverse. So this formula gives a another method to compute the inverse of a matrix, and it is already experienced. This is much suitable for large matrices. Okay. So second important point is if m is a positive integer such that m is greater than n, then we may rewrite the expression as minus 1 power n a power m plus k1 a power m minus 2 plus k2 a power m minus 2 up to kn a power m minus n is equal to 0. What does it mean? It means this showing that any positive integral power a power m of a is linearly expressible in terms of those of the lower degree. So this is the another flavor of the Cayley-Hamilton theorem, which is very important. Both the aspects are very important in the matrix algebra. Now, let us look one type of the problem where it is asked to verify Cayley-Hamilton theorem for the given matrix. Let us suppose this is the square matrix of 3 cross 3, hence, and you also require to compute A inverse. So how you can the Cayley-Hamilton theorem, you can write the characteristic equation of A may be written as A minus lambda is 0. It means now A is this. So just you can write A minus lambda I matrix is like this. Okay, so on expansion, you will get lambda q minus 6 lambda square plus 9 lambda minus 4 is 0. So to verify Cayley-Hamilton theorem, we have to show that, just to show, so we have to show that a cube minus 6a square plus 9a minus 4i is equal to 0. For this purpose, first of all, we have to calculate a square. The a square means a is this, so a into a. A into a, you will multiply R1C1, R1C2, R1C3, R2C1, R2C2, R2C3, and R3C1, R3C2, and R3C3. Then you will get in the form of first row 6 minus 5 5 minus 5 6 minus 5 and 5 minus 5 6. You'll get this. So now you got the a square. This is the most important part. Now aq again you will multiply and you will get in the first column 22 minus 21 21, second column minus 22 22 minus 21, third column minus 21 minus 21 and 22. In this way you can rearrange again. This system means aq minus 6a square plus 9a minus 4i, and adding and subtracting all the matrices, you will get 0 0. You have to verify this. आपको ये करना है वेरिफिकेशन. ऑलरेडी ए क्यूब आई हैव ए स्क्वायर और क्या है ए भी है, तो ए आपको पास है, ए क्यूब है, ए स्क्वायर है. आइडेंटिटी मींस यू नो द आइडेंटिटी मैट्रिक्स, एंड देन दिस इज द सिंपल मैट्रिक्स एडिशन एंड subtraction. So after this you will get this. Okay, so please verify it. In this way you have verified the Cayley-Hamilton theorem. So this was the first type of the problem, and hope you will do the practice nicely. Thank you very much. Thank you.